Welcome to this tutorial. Today we will use Imaris to analyze the cell-to-cell junction protein and the actin cytoskeleton and the distance between those two structures using manually edited surfaces and spots as well. Without further ado, let's revert to the original image here. So I can go to this by just right-clicking and open image only here. So this is a nice trick if you want to keep what you've done but just start over to see if another method is more suitable. And so let's start. So the first thing I want to do with this data set is maybe check its dimensions. So I can go to edit image properties here, and as you can see, this is a quite large image, 2000 by 2000 pixels in X and Y direction, and this is due because it was acquired with a confocal microscope and an Eriscan module. So the Eriscan will increase the resolution of the image, but also the signal to noise ratio. And in this case, because we have very fine structures here, the Eriscan was used to increase this signal to noise ratio, but actually we don't care that much about the dimension, the X and Y dimension. So the first step to speed up a bit the calculations will be to resample 3D here our data set, and let's use 1024 as a size. Should be nice like this, and it will greatly speed up the process. So let's focus on the first step, which is just disable the green channel here. So focus on this cell-to-cell junction. So here I think we could work two ways. We could either use some pre-filtering, that's one option, and the other option would be to just stick with our dataset as it is and try to create the surface like that. So if we're interested in the average volume of this surface, I would probably try to clean up a bit this dataset and doing some light image processing. So let's do this. I will go with the red channel, and let's just don't be too harsh, because I want to use a very light image processing. So I will use the Gaussian filter, and let's use 0.5 microns just to keep the outline like this. Yep, something like this. So with this I can now create my new surface here, and I don't want to classify the surfaces, but I still want the object-to-object statistics, because we will be interested in the distance between this object and the green actin cytoskeleton. So I will keep object-to-object statistic checked and move on. I want to focus on the red channel. Surface details, we can leave this by default, since we have already smoothed the data set itself. There's no need to be too picky about this value here. Let's have a look. We can have a look at 3D as well. So what I would do here, so you have two choices. You can either leave Imaris with the automatic threshold to find the right value here, or you can fix yourself the value. So let's use something like this. 420 should be enough to represent our data set. So now in the next step, so here we don't want to split the touching objects. because it will create too many objects. But what we want to do is filter the surfaces here to keep only the biggest one. So we can use this threshold here, since the current filter is by default number of voxels, and just keep here the only biggest one, and then we can finish. So now we have created our structure, but since this cell-to-cell junction belongs to multiple cells, we want to cut the branches, let's call them branches, here like this, to edit a bit this surface and just keep what is interesting to us. So a quick way to do that is by using the edit tab here, and let me just switch back to the pointer selection so it's a bit clearer of what I'm doing, and we will draw a cut line. So to cut these surfaces here, the cut line will always be vertical, so you have to be aware a bit of how you will proceed. Let's try to focus branch by branch, even if we end up with multiple objects at the end. You will understand what I mean, because now to define this cut line, I have to shift click here on the surface, and you see this blue line, this very thin blue line, is the cut line. So if I cut here, I will be able to remove this branch, but I will also at the same time cut here, and then it will leave me with a small part to cut again. So let's do this. We cut, and then I can select this branch and press delete to remove it. So let's remove this one as well, and let's just go around the cell, the whole cell, by shift clicking, defining cut lines, cutting, and removing the unnecessary parts. Here it's already cut. Yeah, we can probably do a better job. Let's use something like this. Okay, and let's continue and do the rest quickly, like this. Okay, and we have just two more here to cut quickly. Here. And the last one. So there are other methods to cut and edit the surfaces. You could also edit the signal itself, but let's say this is a quick way to get an average volume, and since it's an average volume, I mean, we don't need to be too precise anyway. So once this is done, you can get the average volume by just going on the statistics tab here. And if you go to the detail tab, you will see the volume of the structure that I've selected here. If I go to specific value, you will get the detailed structure here. This is the one that is selected, and actually you can see that we have multiple surfaces, so those are leftovers from our cut job. So I don't know if they are selected like this. Maybe you can remove them. If I do that, delete, yep, go back here. Yeah, that's a quick way to remove objects even if you don't see them, like that. And we are just left with the big structure here, like this. So this is the first step. The next step is to focus now on our actin cytoskeleton here. So again, there are several ways to work. The one I will show you today is how to work with spots, since it doesn't need any additional modules to work with. So let's just disable this surface here. And in order to work with spots, I will just quickly do a measurement. So I will switch to the slice view here. Let me just zoom in, and I just want to have a rough estimation of the size of the spots that I will use to cover those filament-like structures. So roughly 0.4 microns, 0.5 microns perhaps. Yeah, 0.4, 0.45, something like that. So if I just reset the view here, so it can work a bit better, what I'm interested in is defining spots around the innermost part of this network of filaments. So there is no easy answer and no easy way to do that. Since the structure is not round, since the structure is not regular, you will have to do at some point some manual editing. So let's just save us some trouble and let's just do it the simplest way possible. So we can create spots here. We will segment only our region of interest because we don't want to deal with too many spots. We don't need to classify them. And let's continue. So here I will just restrict, sorry, the detection to the innermost part. So I have to grab the handles like this. To define my my region of interest here. And something like that. Okay. Next step, we want to work with the green channel. The estimated diameter, we said it was something like 0.45 microns. We can use backward subtraction to clean up a bit the image, well, in the background, because we don't see the result of it. And now we can just deal with our spots. So, as I said, there are spots outside of this inner circle, there are spots inside. We could add some filters to maybe remove spots with the, for instance, let's just add another filter for the intensity. So the green channel is the second one, the intensity mean of the second channel, to keep only the brightest spots, so we have a bit less of the spots in the middle, for instance. But anyway, any kind of filter you will use will still leave some manual work to do. So let's not focus too much on this here and finish our spot creation. So what you have to do now, and I will just remove here the slice view and reset a bit here the view. I want to edit manually the spots and clear the spots that I'm not interested in, to be left with just one line of spots representing the innermost part of the filaments here, structures here. So to do that, again, I can go to the Edit tab here, and here I will switch to the circle selection mode, and by pressing the control key I can change the diameter of my circle. If I click once, I will select the spots. You don't see this well. If I zoom in, you see that they are now yellow, so that means they are selected, and I can either use the delete tool here or just press the delete key on my keyboard to do the job. So I will do that. It's quite let's say biased obviously, because I will have to do some decisions at some point. Do I want to keep this unconnected line to define my innermost circle, or do I want to use those instead? There is some decisions that I will have to do. So that's sadly there is nothing you can do against that. So I will speed up, or maybe just cut the video here, because it will probably take a long time. Just a quick shortcut is that if you want to select multiple spots, you can press the control key, the one you use to change the size of the circle, and you can, by using the control key, click and select multiple spots at once like this to delete them like that. So let me just do the spot cleanup, and I will be back immediately afterwards. Okay, so I've done a bit of a cleanup, and just to make sure I haven't left too many spots at the wrong place, let's just disable quickly the volume view. And so I have a loaner here, another one here. Maybe this line should be cleaned up a bit again, like this. Well, yeah, and let's finish like this. Yeah, so this should be representing roughly the innermost circle. So now I already have the answer to my question, which was what is the average distance to this red structure. So let's call it cell to cell junction, to the green spots, which are our actin staining. So here, if I look at the statistics from the spots object, and I look at the spatial view, I will see some information here, but what I'm interested in here is sorry, it's the wrong view. I want to look at the shortest distance to surface cell junction. So here I have the shortest distance for all the spots here, and if I have the average value, it will be selected here. So here you have the mean. The average distance in microns is 2.59 microns, the shortest distance between those spots here and the red structure. So that was one quick way to get the answer of the average volume of the cell junction for one cell, and the average distance between the innermost actin filaments or actin structures to the cell-to-cell junction. So that's it. I hope you learned something today, and if you have any questions, don't hesitate to contact me directly, or leave a comment under the video, or by any other means you find useful for you. So that's it. Thank you for listening. Bye bye.